So we just talked about quick sort. The next sorting algorithm that I want to talk about is merge sort. And merge sort also divides an array into two parts and sorts each part and merges. So let's see how this gets done. So it's like merging two sorted arrays. So basically the idea is that you divide an array into two parts. Sort each part, and then merge them. And this is done recursively. Okay. So we'll look another recursive version of recursive algorithm for merge sort. Let's take an example first and see how this gets done. I'll take the same array that we had for quick sort. Let's say we have these elements over here. We have 44, 55, 12, 42, 94, 18, 6, and 70. So what does it do? Just like in quicksort, you have a left and a right pointer, and we have a middle. Divides the array into two parts. And what it does is, this also uses the principle of what we call divide and conquer. And it separates this into two parts. So now you have two arrays, 44, 55, 12, and 42. And we have another array. We have another array over here, 94, 18, 6, and 70. Then it again subdivides this array into two parts, 44, 55, 12, and 42. Okay, then this is further subdivided into 44, 55, and now there's only one element in the array. So what it does is, it will do a merge here, put them together in an array with 44 and 55. Then this is completed. It again subdivides this. This will be 12 and 42. Then again, single element arrays, merges both of them. And in this particular case, they are in the order. Then finally, it will merge these two arrays. So what will I get here? I will get 12, putting them in order into a third array. So compare the top two elements. Okay? Whichever is smaller, you put the guy here. Then you move this one's pointer here. You compare this and this, 42 is still smaller, so you put 42 here, you're done. And then you copy the other array into this part. Okay, so this array, this part of the array is sorted. Again, go through this here. I have 94 and 18. I have 6 and 17. This is not, then again I have 94, 18, here. This will be completed. So it's single digit now. I merge these two guys. 18 and 94 are out of order. So I put it in the appropriate order in a third array. Now again here I have 6 and 17. They are in order. So I leave them as 6 and 17 in the merged array. Now I merge these two guys, these two, and what will I have? I will have something like this. I have 6, 17, The merged array should look something like this: 18 and 94. Now we have two sorted arrays and we repeat the same process of merging. So what do? I compare the top two guys. 6 is the smallest, put it in the third array here. Then this pointer is here. This pointer is still here. Copy, compare both of them. 12 is the smallest. I put 12 here. This moves here and 17 remains here. 17 and 42 are compared. 17 is put into the array and it moves here. 18 and 42 are compared. 18 is put into the array and it's at 94 here. And then you find 42, 44, 55, and finally 94 will be pushed into the array. So the point is, each one of these, remember that merge sort is recursive, divides the array into two parts, and there's a lot of bookkeeping that is to be done in terms of merging these two lists, putting in a temporary array here, and so on. So another temporary array is used. So extra space of n is used. It is possible to do with smaller space of n is used in merge sort. Okay. So now let's write the algorithm for merge sort. And this is again a procedure module. Merge sort. What are the arguments that it takes? It takes an array of integers. By the way, this is just convenience that I'm using integers. It can be strings, it can be floats, as long as you know how to define the order. Then, interestingly, we also pass a temporary array which is the size of a, which is also the size of integers. Then we have a pointer to the left nibble here, right here at every pass through the array. Okay. Left, comma, right, which are again uptype integers. And let's see how this algorithm works. We also need another variable, middle. If left is less than right, what's the meaning of this? The nibble size is still greater than 1, then we assign middle to the value of left plus right divided by 2. Then we call merge sort on each part separately. I always pass the temporary array for the bookkeeping to keep the sorted portion of that particular nibble, left, comma, middle. And we call merge sort again on the other portion. Temp array, middle plus 1, comma, right. Okay. And then we merge each part. Merge a, comma, temp array, comma, left. Remember, every recursive call you have to merge it. Middle plus 1, comma, right. Okay. That means what? Left to middle is one part of the array, and middle plus 1 to right is another sorted portion of the array. And if end module. Okay. Now let us look at this function merge. This is a little more complicated. Although it looks trivial, what we do is I have the A, which is an array of integers. Then we have the temporary array. which is again the array of integers. But as I said, you need n spaces to keep the intermediate values, intermediate sorted nibbles of the array. Then we have int left pause int, or let me write it differently, left pause, left position, right position for the first position of the array, for the first part of the for that left side nibble of the array, and the right end. So after merging, it should go from left pause to right end, hopefully. And these are all of type integers. Okay. Now what we do is we define a variable left end of this particular array, which is again of type integer. We have a temp pause, which keeps the position in the array where the sorted portion is copied, left pause, and number of elements, sorry, this is also of type integer. The total number of elements which correspond to the number of elements in the current sorted list is also of type integer. Now let us initialize all of this. Left end is initialized to right pause -1. Why is that okay? Because I'm talking about, here remember we said middle plus merge sort, middle plus 1. So up to middle, left comma middle is the first part of the array, which is going to be sorted recursively. Then we have temp pause, which is assigned left pause, and is what we have already said, left end. That means what end of the first portion of the array? Right pause -1. Temp pause is pointing to left pause. And num elements, where is it pointing to? Num, not pointing to, num elements corresponds to the number of elements in this nibble of the array that is being processed. Pause +1. Okay. And what do we do? While left pause less than or equal to left end, because I've not reached the end here, and right pause less than or equal to right end, do if a of left pause is less than or equal to a of right pause, put it in its position in the temporary array. Then we have temp array of temp pause plus, I'm just incrementing it over here the C way, a of left pause plus. Otherwise, what do? We copy from the other array. Temp array, other part of the nibble, temp pause plus is assigned the value of a of right pause plus. Okay. End if, end while. Okay. So until all the left portion elements have been processed, this is what we do. Okay. Copy this. Then what we do is, while both of them, so one of them moves and then you're done. Okay, goes to the end of the array, you're finished. But there could still be some elements which are left over in both the limits. So what do? While left pause less than or equal to left end, do temp array of temp pos plus plus. It is assigned the value of A of left pos. That is, the remaining elements which are large are being copied, as we saw in the example a while ago. Okay. Similarly, while right pos less than or equal to the right end of the array, we do temp array of temp pos plus plus, assign the value of A of right pos plus plus and while. Now next, so we have finished everything now. So what we have to do is we have to copy that portion of the array which has been sorted into the array because it's not going to be looked at again. So what we do is I start with an I variable equal to 1, and while I less than or equal to number of elements, I copy from the right end because I know that from the right end it should have been correctly processed. I do A of right end, assign the value of temp array of right end because that's what this whole array was divided into. Okay, the right end of that nibble of the array has been processed, and right end right end -1, and I is assigned the value of I plus 1 end while, and we are done with the merge sort algorithm. We just saw an example already. So basically what we are doing is during the merging process, this is the rightmost portion. Okay, once it's merged, you copy from here to here, whatever it may be. Similarly, when it comes here, it copies from here to here. All right, because the indices within the left and right can get messed up, so you always don't start from 0 or whatever. All right, because we know that the right end exactly divides the array into two parts. Now